Hi guys, welcome back. We're doing operations with matrices today. So might look familiar, might look totally wonky to you. Sounds either way, it's fine. So a matrix is a rectangular array of variables or constants in rows and columns. Right? So a rectangular array just means that it's shaped like this in a rectangle. And it could have variables or numbers in it, variables or constants. It's usually enclosed in brackets, so those funky little things that we see. In a matrix, the numbers or data are organized in a way so that each position in the matrix has a purpose. So each value in the matrix is called an element. So each one of these individual pieces is called an element. So there are 6 elements in this matrix. And a matrix is usually named using an uppercase letter. So in this case, we can see that uppercase letter is the letter A. A matrix can be described by its dimensions, and dimensions, as you know, just means its size. And a matrix with m rows and n columns is an m by n matrix. We read this m by n. So the one that's above here, matrix A, is 2 by 3 because it has 2 rows and 3 columns. Right? So we always count how many rows does it have. In this case, it has 2. And how many columns does it have? 1, 2, 3. In this case, it has 3. Pretty simple in terms of like how we name them. Just basically, I count like how many rows there are, and then how many columns there are. 2 by 3. And then each element can be described by naming the row and the column to which it belongs. For example, 5 is in row 1 and column 2. So if we're looking at this number 5 right here, we would say that it's in the first row and it's in the second column. And so we actually smash those together. Sometimes you might see it as a 1 comma 2, something like that. But a lot of times we just see them smashed together like 1, 2. So it kind of looks like a 12, but it means it's in the first row and it's in the second column. So rows and columns. So I always do rows and then columns. So for example, it says, find the dimensions of each matrix. So in this case, I always count rows first. So I have 1 row, 2 rows, 3 rows. So this is a 3 by, and then I have 1 column, 2 columns. So this is a 3 by 2. And then it asks us what element, what is element A2, 1. So this is in matrix A. It's going to be the second row and the first column. So in the second row here and the first column here, that's going to be this number 4. So A21 would be equal to number 4. We could do the same thing over here. So it wants us to find the dimensions. So I see that there are 1, 2, 3 rows. So this would be a 3 by. I can count how many columns there are. 1, 2, 3, 4 columns. So this is a 3 by 4. And it wants me to find element 2, 4. So, or A24. That's going to be the second row. Right? So it's going to be in this row here and the 4th column. So it's going to be 1, 2, 3, 4. 4th column over here. We can see that the number 20 is what element that is. Okay. That's pretty much just the naming. We're not really going to worry too much about that, but I did want you to be familiar just in case that ever pops up, so you can be a little happier when you're going through. So then adding and subtracting, we worked a little bit with this in the past and this morning when we started. So if we're looking at adding and subtracting, we can only add them or subtract them if they're the same size. And we're going to add or subtract what's called their corresponding elements. So if I look at the first one in this one, I'm going to add it to this first one in this one. All right, so I'm going to do 3 plus 2. And that's going to give me a 5 in that same location. And so the 3 plus the 2. I'm going to change colors so we can see what I'm doing here. I'm going to do -5 plus 0 would just be -5. Put it in the exact same location. Okay, so I have 1 plus -9. That would be -8. I'll put that in the exact same location. And then 7 plus 10 would give me 17. So my ultimate answer would be 5, -5, -8, 17. That's my final answer. You can do the exact same thing with subtraction. Go ahead and try this one here. Or actually, go ahead and do that one together. So I would have 4 minus -3. 4 minus a negative, this would be like 4 plus 3. Or we could say that's just 7. And then this would be 8 minus 10. So 8 minus 10, like that, would just be -2. So you can sort of show like the middle step if you want to, but ultimately our answer is just going to be this section right here. They should be the exact same size. So you see that we have a 2 by 2 and a 2 by 2 make a 2 by 2. And then a 2 by 1 and a 2 by 1 make a 2 by 1. So you can see the exact same size happening there. Okay, go ahead and follow through with each of these here, and then I'll come back in a second. Cool. You may have noticed here when you tried to do C, this one's C, so 8, 6, plus, and then B here, -4, -1, -3, -7. You may have noticed, like when you did this one, that was probably fine, like 8 plus -4. 8 plus -4 would just be +4. But then you kind of got like left out here, like what to do with this guy. And what happens is that you can't really do it. What you call this is impossible, or you could say undefined, everybody's favorite math word, undefined. Undefined. And you just really can't add them. They can only be added and subtracted if and only if they're the same size. Sometimes you hear the word order, or the same dimensions. All those things just mean they have to be the same size. They have to be the same shape, same size. Cool. And then finally, we have one more type of math, which is called a scalar multiplication. You can multiply a matrix by a constant called a scalar. Right? When you do this, you multiply each individual element by the value of the scalar. So this operation is called scalar multiplication. So if we have R, and we know that R is this matrix here, and it asks us to find 5 of the R's. So essentially what we're saying is we want to take the 5, we want to have 5 of these things. Right? So 5 of each of the things that is in here. So what I'm going to do is I'm just going to use basically like distribution. So 5 goes on to the -12, that makes -60, and I always put that in the exact same space. 5 goes on to the 8, and that makes 40. 5 goes on to the 6, and that makes 30. 5 goes on to -16, and that makes negative something. -80, I think. Somebody check me on the calculator. I'm not sure. And then 5 times 4, 5 times 19. So you can get these last two pieces here. Right? The same thing's going to be true when you do 2a. You just multiply the 2 times everything in there, and you're going to get your product out. All right, so scalar multiplication, exactly the same as distribution. If a number's on the outside, it goes into each of the different pieces. So when you look at these ones, the way that I would set this up is I would just say, okay, I have 2 of these things, 2 of the A's, and I'm adding it to the B. 2, -3. And just like in regular math, like when I have something like this, 2 times something plus something else, I would always distribute that in first. I'm going to do the same thing here. So that means 2 times this, 2 times that, 2 times this, 2 times that. That's going to give me something here. And then whatever I get there, I'm going to add it to this same thing, right? Because that hasn't changed yet. And then whatever I get will go in my final answer. All right, so fairly simple as you're working your way through. But if you get stuck, as always, ask questions. All right, love you guys.